Hello, this is Mr. Craig, and this is the answers to the homework on day 18, the precipitate reactions, also known as solubility rules. If you did this homework while looking at your solubility rule sheet, I highly recommend that you try this homework again a little bit later on, maybe in about a week or so, without looking at the solubility sheet. But using it for the homework today is okay. But I would highly, highly, highly recommend that you make the flashcards, learn your solubility rules, because when you get back in August and the test on the second day of class, you will have to know your solubility rules, and you will not have time to memorize them at that point. So what I'm going to do when I explain the homework today is, or right now, is I'm going to go over the solubility rules, but I'm not going to show the sheet. So I will verbalize it, but I will not show you the sheet because you need to memorize these. Alright, so looking at question number 1. And again, be sure that you circle and write PPT. Now with Word, I could not circle these and write PPT, but the box, as you can see with the barium sulfate, that is the precipitate. Alright, so question number 1. We have ammonium sulfate and barium chlorate. Again, what we're trying to do, or what we're trying to achieve, is we want to make sure that the metals switch partners. So the metals are going to switch here, and if I do this, then the ammonium and the barium are going to switch. So now the barium should be with the sulfate, and the ammonium should be with the chlorate, and that's what we have. Again, balance the charges. Alright, now the reason why the ammonium chlorate is soluble, 2 reasons. Ammonium is considered to be, in this case for solubility rules, a group 1A element. Okay, so anytime you have a group 1A element, the compound is soluble. It will dissociate 100%. Also, looking at the chlorate. Okay, so the chlorate, along with nitrate and acetate, means that the compound is soluble. So really, this has 2 reasons as to why it's soluble. The barium sulfate, and I don't remember the numbers. We don't really care about the numbers here. But when we talk about sulfates, all sulfates are soluble except with cold beer and Pizza Hut. And again, the cold is calcium, the beer is barium, the P is lead, and the Hut is the mercury. So we have our barium. That means that barium sulfate will not dissociate in water. So that's what forms our precipitate. So if it does not dissociate in water, if they have a chance to come together, they will form a solid. Okay. All right. Looking at letter B, we have lead nitrate and sodium chloride. Again, the metals are going to switch places here. So I'll have lead chloride and sodium nitrate. Again, let's talk about the soluble. A group 1A metal, sodium and nitrate, along with chlorate and acetate, means that it's going to be soluble. Anytime you have a group 1A metal, that means that it's soluble as well. Alright, so looking at the chlorines, when we talk about chlorine, bromine, and iodine, they're all soluble except with silver and lead with a +2 charge, and also the Hg2 +2. But again, I'm not going to give that to you because that shows up about once every 3 or 4 years on the AP exam. I want you to know that lead with chlorine and silver with chlorine forms a solid or a precipitate. Okay, that's the emphasis. And again, when we talk about chemistry in class, we're talking about things that are going to be on the AP exam. So I want you to be very, very well prepared for that. All right. You'll notice right off the bat we've got a no reaction here, and you should have a no reaction too. Let's talk about why. Well, again, we have a group 1A metal and a group 1A metal. That should be enough. Okay, so when you look at phosphate, phosphate was with, let me try to remember here, carbonate, chromate, I think sulfide. Those are the nonmetals that are not soluble. Okay, in other words, they will not dissolve in water except with a group 1A metal. Well, in this case, potassium is a group 1A metal. It doesn't matter that we have 3 potassiums, but we do have potassium. Also, this is soluble because of chlorate with the acetate and nitrate, and we have a group 1A metal. Okay, so C should be a no reaction. So if you struck that out and then wrote NR, you're in great shape. Letter D, again, looking at the products here, copper 2 oxide, or hydroxide, I'm sorry, and sodium chloride. Again, we have a group 1A metal, so just stop right there. Also, all chlorines, bromines, and iodines are soluble except with silver and lead. Then looking at the hydroxide. Hydroxide actually is not soluble, likes to form a solid, and it will do that except for group 1A, and then in group 2A, calcium on down. Well, copper is a transition metal, therefore it forms a precipitate. Alright, looking at letter E, again, sodium chloride, just like up here, is going to be soluble. Chromium chromate, yeah, that does exist. Chromate's a polyatomic. Chromate, phosphate, carbonate, and sulfide are not soluble. In other words, will not dissolve in water except with group 1A and ammonium. Well, chromium is not a group 1A metal. So that's why we have the formation of a precipitate. And again, this is how you learn the solubility rules, is you say them over and over again, or you write them out over and over again. I hate to say it, but that's how you learn anything, guys. Alright, letter F, ammonium nitrate and silver carbonate. Okay, so again, ammonium, anytime you see ammonium, it's just like a group 1A metal, so it's going to be soluble. Also nitrate. So again, nitrate, acetate, chlorate, those are soluble. Alright, carbonate. Just like with the chromate, the phosphate, and the sulfide, they will not dissociate or be soluble except with group 1A. Well, silver is not group 1A or ammonium, so that's why that forms a precipitate. So if you get this down with the group 1A, anytime you see a group 1A or ammonium, soluble. If it's not a group 1A metal, then you've got to do a little more investigation. You got to take a look a little bit further. Alright, looking at letter G, we have mercury sulfate and copper nitrate. Now again, this is mercury that has a +1 charge for each mercury. Now this is getting kind of dirty. If you put that mercury sulfate formed a precipitate, I think I'd let it slide. I don't believe they do this to you on the AP exam. But if you look at the solubility rule sheet, it says mercury with a +2 charge for all sulfates are soluble except for cold beer and Pizza Hut. And the mercury, the Hut here, has a +2 charge. It's not Hg2 that has a +2 charge. So technically this is a soluble reaction. And yes, mercury does have more than one charge. The reason this is soluble, the nitrates. So I apologize. Letter G is a dirty question, but you won't see anything like that on the test, and you should not see anything like that on the AP exam. I would be stunned if that were on the AP exam. Letter H, we have potassium nitrate, again a group 1A metal with nitrate. Hey, 2 reasons why that's soluble. Strontium iodine, again strontium, even though it's a group 2A metal, we have iodine. All iodines, bromines, and chlorines are soluble except with silver and lead. So that's why this is a no reaction. Okay. Looking here, the lead nitrate, again, all nitrates are soluble, and we have a group 1A metal. Alright, looking at the hydroxide, hydroxide is only soluble with group 1A metals, ammonium, and then calcium on down. Well, iron is a transition metal, so that's why we have a precipitate there. Looking at the sodium nitrate, again a group 1A and nitrate, that's why that's soluble. Lead sulfate, there's our pizza, and all sulfates are soluble except for cold beer and Pizza Hut. Alright, I hope I'm not boring you by saying these rules over and over again, but that's what I want you to do as well. Alright, number 2, on the back side, potassium nitrate and barium chloride. So again, barium nitrate, all nitrates are soluble, so it doesn't matter what metal it's with. Potassium, a group 1A metal, so this is a no reaction. Again, group 1A nitrate here we've got a chlorine. All chlorines, bromines, and iodines are soluble except for silver and lead. That's why we have a precipitate there. Sodium and chlorine, group 1A. That's why that's soluble. Barium chromate, carbonate, phosphate, and sulfide are not soluble except for group 1A. And ammonium. Barium is a group 2A. So that's why that forms a precipitate. We have a group 1A and chlorate. And then for the chlorine, again, all chlorine, bromine, and iodines are soluble except for with silver and lead plus 2. And that's what we have there. A group 1A and nitrate. Getting the pattern here, guys. That's pretty typical. And then phosphate, chromate, carbonate, sulfide are not soluble except for with group 1A and ammonium. Silver is a transition metal. Alright, writing net ionic equations. It would probably be a good thing if you actually wrote out these equations. And let me do this for you since I did not on the homework here. Let me see if I can get some space in here. I doubt if I can. Actually, I'll just let you check these out. Oh boy, I think I might have enough room here if I write small enough. Alright, iron sulfate, that's a +3, so that means we need 3 of those and 2 of those. And potassium chloride, so that means that this will form potassium sulfate and iron chloride. And iron has a +3 charge, so Cl3. So I need 2 there, 3 there, 6 there. So group 1A, so we don't even need to worry about that one. Chlorine, all chlorines, bromines, and iodides are soluble except for silver and lead. That's why this is a no reaction. Alright, aluminum nitrate, so AlNO3, that's a 3 plus barium hydroxide. I'm doing this only because you have it done already. And it forms aluminum hydroxide. And again, barium nitrate, so put a 2 there. Scoot that over just a bit. Alright, so we've got the same number. We do not have the same numbers, so we need a 3 there, 3 there, 2 there, 2 there. Okay. Alright, the barium nitrate, that's soluble because of the nitrate. The aluminum hydroxide, it forms a precipitate. So that's, we want to write out the net ionic equation is the equation that shows the things that make up the precipitate. So we actually should have a 2 there, a 6 there, and a 2 there to be technically correct. Okay, so again, net ionic equation is the formation of the precipitate. Okay. Now I'm not going to work these other ones out, but I'll let you check these out. And again, the big effort or the main focus on this day's lecture is so that you learn solubility rules. Again, you were given a sheet last year. Okay, that was just to teach you how to use the solubility rules. Now that you know how to use those solubility rules, now you need to memorize them. Again, I hope this has helped. And again, make those flashcards, guys. Please, very, very important.